Okay, so I'm here today to talk about a new product we have called CallMom, which is an Android app that serves as a virtual personal assistant, much like Siri. And where the name CallMom comes from an experience we had over the past year, which was, well, even prior to the release of Siri, we had a number of different apps appear that were essentially using PandoraBots as a backend through its API to get conversational responses from the bot. And so we were able to analyze the log files of those conversations and look at the set of things that might be considered device commands or phone commands. So in other words, the non-conversational inputs, which were just related to, sending a text or making a call or searching for information. And it turned out that the number one thing, the most common thing people say to their phones when they have the choice of voice input is "Call Mom." So we decided to name our app CallMom. So it's an Android app that uses voice recognition, artificial intelligence from AIML and PandoraBots, and speech synthesis to serve as a virtual assistant. And it implements a whole bunch of device actions on the phone. We can dial a number, send an SMS message, send an email, learn contact information, change the bot's personality, get info about the app, play a song, search the web, open a URL, read web services, check the battery status, get directions, find a location on a map, and also learn to correct speech recognition errors. As I mentioned earlier, lots happened in the last year in the space of mobile virtual assistants. There are a number of apps for Android, iPhone, and other platforms like BlackBerry and Windows. So, of course, Siri came out this year, and everybody knows what that is. A bunch of these Android apps appeared. Some of them, like Genie, works on Android and iPhone. Evie, the same thing. And let's see, Genie, SkyVI, YourApp24, Iris, BackTalk, and Speak to It all either connect to PandoraBots or have used PandoraBots at some point in their history. So basically, because of all that, because of the enormous activity we saw in this area, we decided to try creating our own mobile app. Of these projects, Sarah, in a way, is the closest to our own design philosophy because it's an open system with an SDK which allows you to create customized applications. So CallMom is really an instance of an application that we can create using the same Java SDK library. So you could imagine creating versions of CallMom for specific types of services such as library information services. And before I just want to continue my tour of this universe of mobile virtual assistants, some of the things we've seen with Siri are kind of interesting. Siri is an Apple app that connects to an Apple server. So if you get the iPhone 4S, you're essentially locked into an Apple product there. But a number of people are trying to break out of that model with different approaches. First of all, there are non-iPhone Siri apps, which means that it's an app that's connecting to the Apple Siri server. There's one called i4 Siri, which is for the iPhone 4 and iPod Touch 4G. There's something called an iJailbreak proxy server, which would allow you to have an app on an Android or another device using Siri's Apple server. So you could make a version of Siri for Android that way. Then on the other side of the coin, there's a non-Apple Siri server, meaning that you could take your Siri app and connect it to Green River Siri instead of Apple's Siri server. Green River has a number of APIs and extensions, and in particular, they can connect to PandoraBots. So you can actually use Siri to talk to PandoraBots. And then all of the apps that I've talked about so far, including Siri, are a combination of the app and a remote server somewhere. And the remote server is usually doing the heavy lifting as far as the artificial intelligence is concerned. But it's quite possible to put the AI itself onto the device. So there's something called Assistant Extensions, which has an AIML interpreter for Siri that actually runs on the phone. And the main limitation with that is that if you have a very large AIML knowledge base, 100,000 AIML categories, it just takes a long time to load on the phone. So once the app is up and running, the response time is quite fast. It just takes a long time to start. But using this, you can, well, actually either using Green River or Assistant Extensions, you can customize Siri's responses with AIML. Calm builds on highly developed AIML Pandora bots. So we've been creating Pandora bots for over 10 years now, and AIML even before that. There's a lot of content available in AIML, a lot of different bot personalities available that we can build on. AIML has always had a kind of scalability advantage over other systems. That means it's scalable in a couple different ways. The response time for a query is more or less independent of the size of the knowledge base. So you can go and add more and more knowledge up to millions of categories and still have very rapid response time. There's another kind of scaling which comes into play here too. Steve Wozniak published an article recently where he was complaining that when he first got Siri, he would be able to ask it questions like, name the 5 largest lakes in California, and it would give him the right answer. And then he went back a month or so later and asked the same question, and it gave him real estate listings. Another example was he asked for all the prime numbers above 87. The first time it gave him the right answer. A month later, it gave him the phone number of a prime rib restaurant. Why does this happen? It's because of the way Siri does pattern matching in its knowledge base. It's using a so-called bag of words model. At least, no one really knows this officially because it's a project within Apple, but Siri came out of an SRI research project, and you can read the papers about that project. And according to what we've been able to learn, the model there is basically disregarding the order of the words in a sentence. So you can see how biggest lakes in California, if there's a specific knowledge category about that, it would answer it accurately. But if then someone put in another category with knowledge about, let's say, the biggest real estate brokers in Lake County, California, then that might be a better match than the original one was. And AIML has always been designed so that we can really avoid this problem, because if you put new knowledge into the bot, it doesn't really conflict with knowledge that's already there. We've got selectable personalities. Learning. We have a couple different types of learning that the bot can do, which I'll explain more in a minute. The AI for the CalmOm application is an open source project that a number of us are working on right now. The idea there is that we can very quickly build up a big corpus of conversational knowledge around these device commands and add to it easily as time goes on, and hopefully attract more people to add to it so that we have a very robust and large database of conversational capabilities for our application. We are very close to releasing this app in a kind of early beta state, simply because we want to get some conversation log data back from users to try to improve the quality of its responses quickly. And the app itself is very lightweight in the sense that all of the AI takes place on the server side, meaning that the phone app itself doesn't have to do very much except process the input and transmit it to the server. The server sends back a conversational response plus maybe some commands to tell the phone what to do. And the phone has to understand those commands. But it doesn't have to do the heavy lifting of artificial intelligence processing on the front end at the phone level. So it makes it very easy to take this same corpus of open source AI and create another app that works on iPhone or another app that works on BlackBerry and uses the same AI knowledge base. That was sort of a description of from the developer perspective how CallMom might differ from Siri and other apps. From the user perspective, there are a number of things that currently both Siri and CallMom can do. We can send text messages, we can send emails, read emails, get directions, teach it some simple profile information, but then there are a number of capabilities which CallMom has already which are not available in Siri. So, for example, you can ask for, do you have any current news about the election? And CallMom will read you back the latest news story about the election. You can teach CallMom contact information. This actually should say, when I say something, I mean something else. And that's a way of teaching the app to correct for speech recognition errors. We can switch over to a different bot. We can check the battery status, take pictures. And because of AIML, there's a lot of sophisticated conversational capabilities which are not available in Siri, like you can say, what are we talking about? And the bot will remember the topic. And then we can do more, we can do deeper personal profile type of learning. My favorite color is green. My favorite movie is the artist, whatever. And the bot will be able to remember all that, deep profile information. We can also say bad answer, and if the app gives an answer we don't like, teach it a different one. In other words, the user can train the bot to say new things. And then there's a few things that Siri can do which we haven't yet implemented. Mainly those that are around the calendar and alarm system. And that's just something we're working on right now. And then Siri's a little bit better at accessing the MP3 system of iTunes than we are at accessing. Right now we're just going out to YouTube to play music. Architecturally, there's a client-side app connected to a server. This diagram down here is just the usual AIML pattern matching, select a template, process the template, send back the response. But the AIML, as you'll see in a minute, has a little bit of extra information in it. We've expanded the AIML language to include a sub-language called OOB. OOB stands for out of band output. Out of band, for those of you who don't know, is a term from electrical engineering, which basically means a side channel of communications. You can think of it as, if you're making a Skype call with someone, the normal mode of communications is going to be your voice and maybe video, but then you might also be sending a text message on the side. So that would be an out-of-band communication. In this case, it means that some of the AIML responses are going to be phone commands, and those are going to be transmitted to the app. The app will not display those commands to the user, but actually take some action on the phone. And here's a very simple example of what that looks like in AIML. The human says, call 911. The robot responds with responding to 911 with your location. And then it's got this little extra OOB information over here that says dial the phone with the number 911. And that looks like a regular AIML category with an extra group of XML tags related to OOB there. And because of the SRAIs, because of the AIML reductions, it's instantly possible to ask for the same request in a whole bunch of different ways. So you can say, please get me 911, I have an emergency, whatever. All of those will link to the same response. Identification.